Let's take a look at some Cloud PubSub concepts. Cloud PubSub is a fully managed real-time messaging architecture. An application that publishes messages is called a publisher. A publisher creates and publishes messages to a topic. To receive messages, a subscriber application creates a subscription to a topic. A subscription can use either the push or pull method for message delivery. The subscriber only receives messages that are published after the subscription was created. After receiving and processing each pending message, the subscriber sends an acknowledgement back to the Cloud PubSub service. Cloud PubSub removes acknowledged messages from the subscription's queue of messages. If the subscriber doesn't acknowledge a message before the acknowledgement deadline, Cloud PubSub will resend the message to the subscriber. Cloud PubSub delivers each message to every subscription at least once. Cloud PubSub enables loosely coupled integration between application components, acts as a buffer to handle spikes in data volume, and also supports other use cases. Cloud PubSub supports pull and push subscriptions. In a pull subscription, the subscriber explicitly calls the pull method to request messages for delivery. Cloud PubSub returns a message and an acknowledgement ID. To acknowledge receipt, the subscriber invokes the acknowledge method by using the acknowledgement ID. This is the default subscription model. In a pull subscription model, the subscriber can be Cloud Dataflow or any application that uses Google Cloud Client libraries to retrieve messages. The subscriber controls the rate of delivery. A subscriber can modify the acknowledgement deadline to allow more time to process messages. To process messages rapidly, multiple subscribers can pull from the same subscription. The pull subscription model enables batch delivery and acknowledgements, as well as massively parallel consumption. Use the pull subscription model when you need to process a very large volume of messages with high throughput. A push subscriber doesn't need to implement Google Cloud Client Library methods to retrieve and process messages. In a push subscription model, Cloud PubSub sends each message as an HTTP request to the subscriber at a pre-configured HTTP endpoint. The push endpoint can be a load balancer or Google App Engine standard application. The endpoint acknowledges the message by returning an HTTP success status code. A failure response indicates that the message should be sent again. Cloud PubSub dynamically adjusts the rate of push requests based on the rate at which it receives success responses. You can configure a default acknowledgement deadline for push subscriptions. If your code doesn't acknowledge the message before the deadline, Cloud PubSub will resend the message. Use the push subscription model in environments where Google Cloud dependencies such as credentials and the client library can't be configured, or multiple topics must be processed by the same webhook. A push subscription is also ideal when an HTTP endpoint will be invoked by Cloud PubSub and other applications. In this scenario, the push subscriber should be able to process message payloads from Cloud PubSub and other callers. You have a choice of execution environments for subscribers. You can deploy your subscriber code as Cloud Functions. Your Cloud Functions will be triggered whenever a new message is received. This method enables you to implement a serverless approach and build highly scalable systems. Alternatively, you can deploy your subscriber application on a compute environment such as Compute Engine, Container Engine, or App Engine flexible environment. Multiple instances of your application can spin up and process the messages in the topic and split the workload. These instances can be automatically shut down when there are very few messages to process. You can enable elastic scaling using Cloud PubSub metrics that are published to Stackdriver. With either approach, you don't have to worry about developing code to manage concurrency or scaling. Your application scales automatically depending on the workload.